Hello everyone. Our topic is about Newton's second law of motion. Force, mass, and acceleration. If an object is at rest, it takes a force to make it move. If it is moving, it takes a force to make it go faster, slower, or in a different direction. So all objects resist a change in velocity even if the velocity is zero. This resistance to change in velocity is called inertia. The more mass something has, the more inertia it has. Any change in velocity is an acceleration. Change in velocity involves change in speed, change in direction, or change in both. So, the more mass something has, the more difficult it is to make it accelerate. Resultant force. The resultant force is the difference between the two forces acting in opposite directions on an object. The resultant force is zero if both forces are equal. The object is accelerating if the resultant force is not zero. Take a look at the diagram. The forward force is equal to 100 newtons. The force of resistance is equal to 50 newtons. The two forces are unbalanced. Hence, the resultant force is equal to 50 newtons. Newton's second law of motion can be described by this equation. Resultant force is equal to mass times acceleration. Or this can also be represented by letters. F is equal to m times a. Force is expressed in newtons. Mass is expressed in kilograms and acceleration is expressed in meters per second square. Newton's second law of motion is also known as the law of acceleration. The equation shows that the acceleration of an object is proportional to the resultant force on the object and inversely proportional to the mass of the object. In other words, the acceleration of an object increases if the resultant force on it increases and decreases if the mass of the object increases. Now we are going to use the formula to solve problems. Here are the sample problems. Problem number 1. Calculate the force needed to accelerate a 22 kg theta at 15 meters per second square. We will use the formula F is equal to m times a. Or force is equal to mass times acceleration. So from the problem, mass is equal to 22 kilograms and acceleration is equal to 15 meters per second square. So we will now substitute the value to the formula. We have 22 kilograms, which is the mass, multiplied to 15 meters per second square, which is the acceleration, gives 330 newtons. So, the force needed to accelerate a 22 kilogram theta at 15 meters per second square is 330 newtons. Problem number 2. What acceleration is produced by a force of 2,000 newtons acting on a person of mass 80 kilograms? Our formula is F is equal to m times a. In this problem, we are looking for the acceleration. Given are the force and the mass. So since we are looking for the acceleration, we need to derive the formula. And now our formula is A is equal to F divided by m, or acceleration is equal to force divided by mass. Now we are going to substitute the values given in the problem, where force is equal to 2,000 newtons divided by the mass, which is 80 kilograms. This gives 25 meters per second square. So the acceleration produced by a force of 2,000 newtons acting on a person of mass 80 kilograms is 25 meters per second square. Let us now compare mass and weight. Mass is the amount of matter, while weight is the force of gravity exerts on the matter. Mass always remains constant. It does not depend on gravity, while weight depends on gravity. Weight is equal to mass times gravity. The weight of an object changes if the gravity changes. Mass is measured in kilograms, while weight is measured in newtons. Let us proceed with gravity and weight. Gravity is the force the earth exerts on you. The force of gravity changes with location. Weight is a measure of the force of gravity acting on a mass. So we have the formula, weight is equal to mass times gravity, or W is equal to m times g. Weight is expressed in newtons, mass in kilogram, gravity in meters per second square. Take note that on Earth, the gravity is 9.8 meters per second square. This is Teacher Rose of Woodrose International School. Bye.